Hello everyone, my name is Ismoilova Gulnigor and I am a student of Tashkent State University of Economics, Faculty of Business Administration. Here I am studying at the first year bachelor degree in World Economy field and my group is MO29. Today I am going to present my final exam work, which is about analyzing the impacts of manufacturing affecting good exports and GDP per capita in Italy. So let's get started. We'll do this final exam work within Stata. And for making data, we have too many requirements. And let's begin with first one, getting your country's data from World Bank Open Data as an Excel file. We just go Google and write World Bank Open Data. And this is World Bank Open Data's official website. We just click it and this screen will appear. We have two options for finding our information by country or indicator. We'll choose country. And here is all countries. As my country is Italy, I'll go I. And here is Italy. As you can see, there is all information is about Italy and I have to download them. As I mentioned before, I need Excel file, so I just click Excel and here is our downloaded Excel file. As you can see, there is three types of data, metadata, countries, and indicators. We don't need metadata, countries, and indicators. We just need data. And from data, we'll choose 4 or 5 variables for our data, as much as you want. Um, Actually, I have prepared all the things beforehand. I have chosen my variables. As you can see, it's exports of goods, services, and primary income, and manufacturing, GDP per capita, and indicator name, which is actually years. And I have to paste it into a new sheet. And here is our pasted variables into new sheet. Everything is good, and this Excel file is ready for importing into Stata. Okay, now we'll open Stata and go File. From there, we'll choose Log and Begin. And we have to give name for this file. Let's name it. Sorry, Italy log. Let's save it. And we'll go again File and choose Import, Excel spreadsheet. I'll click Browse button, then choose Italy Excel, open. We have to choose import first row as a variable name. As you can see, there is letters. If we click this button, then our variable's name will appear. Okay, you can see our variables are already appeared, and let's check if everything is okay with them or not. We just write BR, and as you can see, GDP per capita, manufacturing, and good exports are in black color, while years in red. This means Stata is considering this variable as a strange variable, and we have to destrange this variable. How we can do this? We just go data, and from there we'll choose create or change data, and other variable transformation commands, and choose convert variable from strange to numeric. Okay, and we have to choose strange variable. As you can remember, it was years, and we have to give new name. We just change its name. We just write year without s and save it. Okay. As you can see, new variable is generated, and we have to delete this one. How we can delete? We just click it and drop selected variable. Yes, let's check. As you can see, everything is now in black. And this means everything is all right with these variables, but my dependent variable is manufacturing, and I want that manufacturing should be in the first column. How can I do this? I just go data and comment part, and I just write move and choose manufacturing before GDP per capita. Enter. As you can see, manufacturing is in the first row now. Okay, we just go checking. Okay, everything is good. And we have to save it. Let's save it. Hmm, Italy. Italy. GTA. Save. Okay, now we will begin our final exam work. Analysis, I mean. We need do file. If you don't have do file, you just choose this do file editor and create your own do file. But I have already prepared my do file and just choose this file, and from there I'll choose Italy do file. Open it. And here is my do file. First of all, I give log begin, as you can remember, and then comment browse for checking. Now it's time for ssc install sdoc. We will give this comment because we need my file doc when we are going to take our graphs or such kind of things. So we just give this comment. Just choose it and press execute button. Okay, after this, we'll give a sum for something is happening. We'll choose as sum and press execute button. As you can see, here is our uh, my file doc. We'll choose my file doc, and here is our descriptive statics. Um, as you can see, in the first column we have our variables, then observation years. For manufacturing, it's 33 years, and etc. And the next is mean. What does mean means? Mean is average, mathematical average. 4 years, for example, it's 1991. And standard deviation. Standard deviation means how far or near is located information uh, from mean. For example, for year, standard deviation is 18.33. And minimum and maximum. Minimum is minimum point and maximum is maximum point. Minimum for example, minimum for year is 1960 and maximum year is 2022. Okay, we just copy this descriptive statics, copy, and take it our work analysis and results part, descriptive statics. As you can see, here is some information. This table shows the summarization of Italy's data. In the first column, we can see that variables are appeared. Second column describes the observation numbers, which means 63 years data is observed and goods exports observed for 53 years, and same interpretation with other variables too. Mean presents the average point for each variable. For example, average point for GDP per capita is 248 73.108. Standard deviation describes variables how far or close the mean point. Manufacturing standard deviation value is 1.690, and for year it's 18.33. Mean means the minimum point of the variable, which in good exports is 1.324. Maximum is maximum value of variables. To example, maximum value of manufacturing was 3.98 points. Okay, now we'll go stata again. Say that again and give the next comment. The next comment is TS set years. Okay, this is variables. This means from this year and this year our the observation year. This means observation years from 1960 to 2020. Okay, now next comment. Two-way. Two-way TS line graph. We'll give this comment and have this graph. As you can see, we have our dependent variable. Manufacturing is in the y-axis and years in the x-axis. In this graph, we are seeing the movement of manufacturing throughout 1960 and 2020. From this graph, we can conclude that manufacturing has witnesses growth throughout years for about 400 points. Okay, we'll just copy it. Copy it and paste it into our file. Scatter plot, not this one, sorry. This line. This line. The line graph shown above depicts the relationship between years and manufacturing. Manufacturing reached in its peak with 3,100 points in around 2006. In general, during the period 1960 and 2020, manufacturing showed a positive relationship with approximately 400 units. Okay. Uh, the same thing with other this line graph. For example, we'll learn good experts and years in the next line graph, TS line graph, and GDP per capita and years. And here is the combination of TS line graphs. You can see it. So we just go data and give next comment. Scatter. Okay. Here's here is sorry. Here is our scatter graph. This scatter graph, copy it and paste it in our work for word work. Scatter plot. Okay. Scatter plot above demonstrates the relationship between dependent and independent variable transport service. While manufacturing get a value of 2040 450, good experts gets approximately 2000 points, which is in there and in there. Okay, we'll do scatter plot with other variables. Good experts, just go there, those data, give next comment. Two-way. In two-way, we also have our fitted value. We just copy this graph and paste it into world work. Here is given graph depicts a relationship among manufacturing and good experts. There is a positive relationship between those two variables as the line fitted value grow. As you can see, fitted value is this red line and it's growing. So we can conclude that there is a positive relationship between good exports and manufacturing. We'll do the same thing with other variables, years, and manufacturing GDP per capita, and good exports and GDP per capita. As you can see, all of these variables have a positive relationship. So we go state again and give the next comment. Our next comment is PV core, Pearson correlation test. Okay, here is our Pearson correlation test. Mm, Pearson correlation test, manufacturing year, good exports, GDP per capita. Okay, significance. For this, we just give this comment. We have to give a stock between this, sorry, in front of this comment in order to take my file doc. For this, we just delete this my file doc and give a stock. Sorry, stock. Okay, now we have my file doc. Peer-based correlation. As you can see, in the first column we have our variables, and we'll learn their relationship. Let's copy this and take it into our work. Pearson Payres correlation. 1 unit increase in manufacturing costs 19th increase in year, and 27 increase in good exports, and 81 growth in GDP per capita. Except year and good exports, all other variables have significant correlation of the p-value. P-value should be lower than 0.005 in this test. Okay, now we go state that again and give the next comment. Our next comment will be p-norm. P-norm. Okay, we have p-norm now. Uh, let's copy it and take it into our work. Okay, this is our p-norm. In this p-norm, we are we learned something. So we just paste it into our work, and here is other p-norms for good experts, GDP per capita, year, and manufacturing. So let's go data again and give the next comment. Let's give next comment is histogram. Okay, let's give histogram, and here is our histogram, which explains the density. In this histogram, we have to get bell shape. If it's in bell shape, it will be normally distributed. So we just copy this and take it our paste it our work. Okay, histogram. This histogram describes the information about the distribution of dataset. Shape of distribution should be bell-shaped. Bit size are the same in year. Okay, let's we have our histogram for manufacturing. Let's see how it is. It's in bell shape. Manufacturing is positively skewed because it's in the right direction, and it's normally distributed because it's giving the bell shape. It's clear that highest mean is very close to 2.5 thousand. Okay, we'll do the same histogram for other variables for GDP per capita and good experts. Okay, now we'll go data again and give next comment. Our next comment would be graph box. Now, this is Graphbox. What is Graphbox? Graphbox means Graphbox explains all informations 75% in this blue graph, and these two lines called outliers this is minimum and maximum points. For this line is called median. Okay, we just copy it and paste it our world file. Or given box above describes the 75% of the data. The median located inside the box is equals to 1991. Two lines that span from first quartile give 25% of information. Okay, we'll do the same graph box for other variables manufacturing. In this box plot, median point in manufacturing is 2.7, which represents the central tendency of dataset. Outliers, which are individual data points that fall outside the whiskers, are displayed as individual points. 0 and 6.1 in this box are the outliers. And here is the combination of our graph box. Okay, and we can compare our graph boxes. For example, comparison of good experts graph box and manufacturing graph box. Okay, now we'll go data again and give next comment as well. Okay, this is our as well. Shapiro-Wilk test. Shapiro-Wilk test. Let's copy it and take it our work. Here is our Shapiro-Wilk test. Shapiro-Wilk test checks if a statistical test used to assess whether a dataset follows a normal distribution. The value of V ranges from between 0 and 1. In our result, all of our variables are normally distributed as they very close one. In this table, all of our p-values are significant except manufacturing within 71 percentage. P-value need to be lower than 0.005, which is 5.5 percentage. Okay. Now we go data again and give next comment. We have to give Spearman correlation in there, but okay, now we'll give. Okay, Spearman test. Spearman test is a test. It's a test that analyze the monotonic relationship between variables, and in this test we have to give our dependent variable in the first. As you can see, my dependent variable was manufacturing, and I put it in the first place. And now we can and and we can see that the relationship. Okay, now we'll copy it and take it in our work. Okay. Spearman correlation describes the monotonic relationship between variables. 1 unit increase in the year can cause 92% increase in manufacturing and 36% increase in GDP per capita. 1 unit raising in goods exports can lead to 44% growth in GDP per capita category. Okay, now we'll go say that again. Our next will be as dog regression. Okay. Execute button. Okay. Now, as dog regression, let's copy it and paste it in our Word file. Okay, linear regression. Linear regression represents the linear relationship between dependent and independent variables. In this regression, observation number is 33. F-test assesses the overall significance of linear regression. In our regression, F-test equals 22.894 and the probability of the F-test is 0, which means the relationship between dependent and independent variables is significant. R square means that our 70 percent dependent variable manufacturing is expressed by independent variable, while the rest of it, which is 30%, is stated by other factors. Coming to the coefficient part, it describes that one unit increase in the year has a positive effect with 7.283 points in fuel imports, and one unit rise in GDP per capita affects 27 to independent variable fuel imports. Standard manufacturing. Standard error quantifies the variability of uncertainty associated with estimated coefficient. For example, standard error in GDP per capita category is equal to 37, which demonstrates the fact that there are a few errors in the analysis process. T-test or student test describes that every independent variable has a hypothesis. This test also has a p-value that needs to be lower than 0.005. When the p-value of the test is lower than 5%, that means the variable is significant. In this test, every independent variable is significant except GDP per capita, so we accept the H0 hypothesis and reject HA hypothesis in this variable. Okay, just go state that again and give next comment. Historical regression, robust. Here is our historical regression, robust. Manufacturing. As you can see, this is very similar our previous linear regression. We just copy it and take it our work. Robust linear regression is designed to be more resistant to the influence of outliers and deviations from assumptions compared to traditional linear regression. In standard error categories, the values differs to, for example, the year is 452 errors in the robust, while in traditional linear regression it equals to 5.2092. Okay, next comment would be alpha test. Alpha test. Okay, we just copy it and paste it our Word file. Alpha test. The alpha test assesses significance of the relationship between the independent variables and the dependent variable in regression analysis. The coefficient is 0.0353, which indicates the statistical significance. Okay, what's that with? Uh, we just copy this SSV file and paste it our Word file. With variance inflation factors for independent variables, which is the indicator of problem of collinearity in analysis. With value should be lower than 10. If it's lower than 10, that indicates that you don't have problem with collinearity. In our VIF value is higher than 10, which describes that our analysis has problems with collinearity. So we'll go data and give the next comment. ANOVA test. Predict y hat. As you can see, we'll give this comment and in there among our variables the y hat will appear. Let's check. Okay, here is our y hat. Then close data and give next comment. Okay, histogram linear prediction. Histogram linear prediction, we just copy it and paste it our Word file. The predicted value is not positively skewed because the cursive line is not in the right side and it's not normally distributed because the line is not in the shape of bell. It's clear that the highest bin is very close to 1.6%. We'll do y hat graph box. Data. Graph box for y hat. Execute button. You can see we just paste it and just copy it and paste it into our Word file. Given box above describes the 75% of the data. The median located inside the box is equals to 2.6. Two lines that span from first quartile give 25% of information. One in the up describes the highest point in prediction, which is 3, while the opposite one is 1.7. We'll give y hat as well and residual histogram in the next comments, and this graphs will appear. Okay, we'll do this. In the last part, go just state again, do all of this and file, choose log and close. This is our analysis, how all things will done. Okay. This is our work file that I have done. Now we'll go our 20 requirements. I have done importing Excel into data, so I put plus sign there. I have created dta file and log file as well. And I have done analysis part, word interpretation. Okay, I have done these things. Let's go PPT, which was our independent work. As you can see, the economy of Italy. This was our independent work, which is given to us from our teacher. From there, I'll just show you literature review part. I have to do this from Elicit. So this is our ready literature review and references and PPT. You can see I have done all the 18 criterias. So Let's go. Requirements and put plus sign in there as well. And for illicit literature review for presentation. Okay, now this is the first part of our data. The next part will learn other things also. Goodbye.